Welcome to Bawashir Electric again. So again we are going to see how to deal with our PLC logo Siemens, and we are going to see how to come up with the ladder logic. Actually the basics here is only how to come up with the ladder logic, and this time we are going to look at reverse and forward direction control of a motor using the logo Siemens PLC. So we are going to first design our power circuit. We are going to have here power supply, and we are going to have our 3D components. We are going to have a circuit breaker, then we are going to have contactors. We are going to have a forward contactor, and we are going to have a reverse contactor. Then we are just going to have one thermal overload with it. Then we are going to have a motor straight away. Oh, the space is done. We are going to have a motor. So we can do here our wiring. Let me zoom a bit. Shall have our cables like that, through the main contactor, through the overload, then down to the motor. So now we design the reverse and forward. Shall have line 1 around here, and the line 1 shall go to line 3. Then we shall have line 2 shall be maintained, shall go to line 2, and we shall have line 3 shall come to line 1. So that is our power. I think it's done. So now we are going to have our control, and our control we are going to have this time we are going to have the stop push button, we are going to have the forward push button, we are going to have the reverse push button, then we are also going to have the forward indicator and the reverse indicator. So this time also our overload is going to go to the PLC. Then also we have our control breaker, and this one shall be a 2-pole. Like that, and we shall give it some live and neutral supply. That is live and that is neutral. Let me zoom a bit. So this is neutral here. So now again our live, we are going to have it, that's neutral cable. I'm going to get a live cable, and it's going to go across our gadgets, input gadgets, and we use the normally open line. Remember I told you, if you will see the symbol of this one, the normally open is 3 and 4, all of them 3 and 4, 3 and 4. So 3D can make this one is a stop. Yeah, it's that one. This is stop. This is, so this one is input 1, high 1. This is input 2, I2. Okay, this one let's make it input 2, because input 1 I'm going to give to the thermal overload. This is input 2, what am I doing? This one is input 2, this one is input 3, and this one is input 4. So that's how we are going to do it. So before we have to give our gadget power. Allow me extend it a bit. We are going to give it power, and its power, let it get from here. That is pin 1 for power. Then neutral is going to get from around here. That is neutral P2. So P input 1 is this one, which is here. We are going to leave it for the overload. So this one is going to come at input 2. Which is this one, and this one is going to come at input 3, which is this one. Then this one is going to come at input 4. Which is that one. Now when we have our lamps, allow me to extend a bit. We shall have, let me give them the neutral. Like that. And now when we give them here, this lamp, I'm going to give it Q. This is Q, Q1, Q2, Q3, Q4. I'm going to have here Q4. I'm going to have this one. I'm going to give this one Q4. Then I'm going to give Q3 this one. Like that. Then now we power our contactors. Q1 is around here. When I get this contactor from here, and I give it to Q1. The output. Can give the output of Q1 from here. Then this one we give it to Q2. The output is here. Like that. So now we get the live and we feed the commons. This is live. So we are going to give this common, we give it live. Allow me zoom for you. Then also this common, we give it live. Also this common, we give it live. Also this common, we give it live. Are you seeing? So these are the commons. Normally open, normally open, normally open, normally open. There we go. Then also we are going to get power. Remember, power is here. We are going to give to the overload. That's 95 and 96. So we are going to give 95 power, which is here. Now when doing wiring, don't break the cable in the middle. Here you can give to this pin, or this pin here, or this pin. It is the same. Then from the overload, okay, let me do like this. Let me get from here, like that. Then from the overload we are going to give this pin here. Are you seeing? We are going to give, that is input 1, something like that, are we there? So that is input 1 is for the overload, input 2 for stop, input 3 for forward, input 4 for, we can name them. So when we do the naming, this one is going to be input 2, 3, 4. So when I have here text, I'm going to have forward, oh, it is too big, the font just reduce to something like 16. Okay, so we are going to have here forward start, forward, then I'm going to have another text, reverse. I'm going to put it here. Then I'm going to have another text, stop. I'm going to put it where? Here. Then for the switches, I'm going to have FX start, that is forward start. I'm going to have it around here. Then I'm going to have another text, that is RX start, that is a reverse start, and I'm going to have it around there. So that is it. What's remaining, we do the ladder logic. So our ladder logic, actually I don't have space. Let me try to remove these ones to create some space for ladder. Just going to have them, oh, I'm going to have these ones, they are going to shrink for me. Just like that. I'm going to have this one. Just like that, here join. So now we are going to have our ladder logic. I'm going to come here and have a positive, and come here and have a minus. I'm going to have our ladder logic programming. Now normally open, we are going to start. This normally open is for the emergence, I mean for the overload, because we passed in the normally closed of the overload, so we use here normally open. That means when we power this one, it will have to do what? To close. But had we passed in the normally open of the overload, then in the ladder logic it would be normally closed. Are we there? Let me zoom a bit our program. So now we are going to have normally closed for the stop. Then we have forward start and forward launching. Then we have a forward coil. From forward coil we shall have a start for the reverse, then a launching for the reverse, and then we have a coil for the reverse. There we go. Now we get our cable through the overload, through the stop, through the start for forward, then this one is going to latch up to this way, like this, like that. Then here to the coil, also here to the coil, and here is launching. Then here is also launching. Then we have our neutral, like that. Then we have our lamps, shall have this one for the reverse, and this one is for the other one for the forward, this one for the reverse. We shall have them go through like this, and now they will use normally open. This one will be normally open for the other, normally open. So we shall have this from here up to this one, from here up to this one, from here up to there, and that one like that. Then the neutral like that. So this diagram here is programmed using TIA portal and fed into our device here. So now here in ladder logic programming, it is addressing which is more unique. So this one we have input 1, that is I1. This one is I2, input 2, that is 1, not I2. Then this one is I3, not 4, 3. And this one is I4. Then this one is Q1 for forward. This is Q2 for reverse. Then this is Q3, and this is Q4. It wants to rain. So here it is forward is on Q4. So Q4 is forward, and I will name here forward is powered by Q2, and here reverse is powered by this is Q2. Then this one is Q1. Are we there? So Q1 is the forward, powers this one, Q4. Also Q2 is the reverse, powers this one, Q3, which is the reverse. Are we there? So I think this one here is Q2, and this one is Q1. There we go. So this one is our MCB, and this one is our MCCB, and this one our contactor here, it is Q1, and this one is Q2. I've changed these lamps there, they will give good signal. So what we are remaining with is giving our contactors neutral. Our contactors need the neutral. So we have here this line here, it comes and it joins this A2. Then from there we are going to raise them up to the neutral. Yes. So I think we are done. Let's do our simulation and see. Now with our simulation, we are going to click here play. Then you are going to put main power. control power. You see, once you put on control power, our PLC is on. Now with an overload is already closed, what I've told you, is already closed, and input A1 is reading. So when you press forward start, you see our motor is running in forward direction. Let me show you. Forward direction. As you see, this is a forward direction. Okay, and now when you press stop, then you press reverse, you see it is now running in reverse direction with the reverse contactor here with the reverse indicator. You see what is happening in our ladder logic. So here in PLC we have only input 2 and 3. I mean output 2 and 3. That is the lamp and this contactor. You press stop, it goes off. Forward, you see it is in forward. Stop, reverse, you see it is in reverse. So that is how we do. Actually here the physical wiring, that's how we do it. But this ladder logic circuit we use programming software such as TIA Portal. Then we feed them in our PLC in case when we have any. Then the power line remains like that. We feed our gadgets like that, and everything is neat. Thanks for watching. Please don't forget to subscribe and share. See you when you see me.